The next speaker is Professor Kazunari Sasaki of Kyushu University. Professor Sasaki is a leading scientist of material and process research, fuel cell research in the world. He is currently the associate director of our WPA program, I²CNER. And the title of the speech is Fuel Science, Current Understanding and Future Challenges. Please, Professor Sasaki.
Thank you very much for the kind introduction. Distinguished guest, my ladies and gentlemen. The topic of this presentation is on the fuel cell science. I think we have actually not yet defined the fuel cell science, and that is actually the topic of this WPI in the next 10 years. But we want to consider what could be the science in this very important technological area. I would like to also show one example how the one research division may also work, where we focus to consider the scientific aspect and fundamental research, but we should also contribute to the technological development and should also contribute to the realization of carbon neutral energy society. And that is actually the common goal of this International Research Institute. I think that as Petros has mentioned, we have actually the holistic energy system approach in this WPI. Of course, we should realize the carbon neutral energy society. Of course, these technologies are important, and there are several key technologies which can also realize and contribute to the low carbon energy society. Of course, the fuel cell related and hydrogen related aspects are, of course, essential to realize the hydrogen-fueled energy society. And also green hydrogen production is also essential, and this is also a topic of this hydrogen production research division. On the same time, we should also work to consider how we can manage with CO2 emission, and we have several research divisions, including the CO2 separation, but also geological storage as based on as the next speaker will also present. And I should also mention that without the fuel cell technologies, we cannot realize actually the hydrogen-fueled society. Therefore, the fundamental science and fundamental research in fuel cell technology is, of course, very important. I'd like to mention that there exist several technologies in fuel cells, and of course the fuel cell is not something on the textbook and becoming actually the reality. I think there's many people have tried to drive these fuel cell vehicles. Now we have the very advanced fuel cell vehicles, and as Mr. Higashi has mentioned, the industry has planned to start the commercialization from 2015. We have also, we know, of course, also know that the stationary fuel cell systems can be also commercialized, have been also commercialized, and that is also very important research energy systems in the stationary applications. Actually, without fuel cells, we cannot, of course, convert hydrogen into the electricity. Therefore, of course, the fuel cell technology is important. And so we can also generate the exhaust heat, and we can also use that exhaust heat so that we can also increase drastically the total energy efficiency. I should also mention that the reverse reaction of the fuel cell electrolyzer is also very useful, so that actually we can use the hydrogen and the electricity as the secondary energy carriers. And from this point, the fuel cell is actually very important technologies. And that is also one slide that in our country, we can now buy actually the fuel cell system, and first generation has been also commercialized, but of course there are many technological issues and many breakthroughs are of course required and desired for future development. The research in fuel cells are not limited to our country, of course. In other countries, for example, of course, the United States, but also in Europe, there are also considerable activities for such the commercialization. Today we have the Hydrogen Energy Forum, where we have also presentation from, for example, General Motors from the United States, but also in Europe, there are also considerable effort to realize the Hydrogen Energy Society. There is also other many activities in the field of fuel cells, and one good example is high-temperature fuel cells, so-called solid oxide fuel cells. Now, using such next-generation fuel cells, we can also achieve actually the electric efficiency approaching 50%, and that is actually what we can achieve only using the advanced combined energy cycle, for example, and power plant. Of course, portable application is very important. I think many people use iPod and such mobile devices, so that in the future, we should also keep in mind that such energy issue in such portable application must be also keep in mind and taken into account. From technological viewpoint, there are, of course, many roadblocks, including operational range limitation, because the typical operational temperature of polymer electric fuel cell is limited to the 80 degrees Celsius. The typical operation temperature of the current solid oxide fuel cells are limited to the 800 degrees Celsius. Of course, if we can change such operation temperature, we can actually make the much more broad application or realize broad application of this electrochemical conversion. Durability is a very important issue. Otherwise, we can also realize such devices, and that means we cannot realize a hydrogen-based society. And I think we have many opportunities using these electrochemical devices, so that not only the cogeneration and the fuel cell vehicles are the application, but also we have more opportunity to realize such electrochemical conversion in various energy sectors. If we summarize the operational temperature of such high-temperature system, for example, of course, the current technology is limited to the high-temperature area or the operation at 800 degrees Celsius. But if we can reduce, for example, operational temperatures, we may also realize such, for example, portable devices, which can also help for portable devices of the daily use. On the same time, we should also keep in mind that the possible fuels may also considered, because not only the hydrogen, but also other various hydrogen-containing fuels can be also applied using these advanced fuel cell technologies. Of course, the WPI is a scientific research institution, and we should also consider what should be and what could be the science of these electrochemical devices. And that is, of course, one of the very important topics of discussion within this WPI. If we see the fundamental reaction in these electrochemical devices, we at least need two materials. One is electrolyte, conducting only the ions, but sometimes practical materials has a mixed conduction with non-negligible electronic conduction. We need also two types of electrode. One is a cathode for the oxidant, for example, air, and the other is the anode, where hydrogen will be also supplied. Such electrochemical performance will be determined actually by the interfacial processes, especially on the surface of the electrode, but also processes at the three-phase boundaries areas are very important. Based on this consideration, of course, we can easily find many scientific issues which has not yet been solved, but fundamental understanding of such processes can also make many breakthroughs for such electrochemical devices. From the understanding, a good question is actually, is the interface actually the fast transport path or the slow transport path? Because we have many interfaces. Of course, three-phase boundaries are important, but also grain boundaries in electrode and electrolyte. It could be also affect the transport properties considerably. We may also understand the atomic and molecular scale reaction processes For example, recently we have good procedures like quantum chemical calculation so that we can actually have the understanding of the atomic and molecular level processes. In this field, in the literature, there are many discussions, and tough discussions sometimes, what is actually the nanosite effect and also stress effect. In the literature, there are many or several publications showing the considerable increase in transport properties in such materials. It is very interesting to apply such phenomena to the real application, but before we start to consider the application, we should also understand what is going on and what is actually the effect from fundamental viewpoint. There are many materials issues to mention. For example, in order to apply it or to develop actually portable fuel cells, we should also prepare very thin or miniaturized devices. And we then maybe also used, for example, various technologies developed in electronics, for example. And then downsizing of the fuel cell is, of course, very important issue. Lowering the temperature of the solid oxide fuel cell is one important issue, but we also know that the high temperature polymer electric fuel cell could also solve many system problems. So that could be also very important topics and challenge, but we should have the good electrolyte materials and suitable electrode materials for this type of applications. There are device and system issues. For example, the carbon neutral fuel cell may be also attractive, and that this could be the direct solution to realize the carbon neutral energy society. But also durability and also flexibility is determined by actually the thermochemical understanding of the processes and also understanding of the kinetic process are very important. And these are actually the key issue which could also help to establish the principles of the fuel cell science in the future. During the preparation phase of this WPI, that was almost 1 year, so we have many discussions, very often at the weekend. We have almost no weekend during the last one year. Of course, there is researchers from fuel cells, but hydrogen area, mechanical science, material science, chemistry, and geology, for example. In this WPI, of course, we should develop interdisciplinary science, and we have discussed what could be the common science. Otherwise, our proposal could be just a patchwork of the different activities. During this discussion, we have realized that actually the interfacial processes are very critical and common in each scientific field. I think the hydrogen storage, of course, many people know that. Of course, in this process, the hydrogen incorporation and also diffusion and also solubility of hydrogen is, of course, important. As Professor Robrich has presented, that chemical transport of the hydrogen in such metallic materials are, of course, very important. And also in the field of geology and the ocean sequestration, of course, CO2 transport in the earth or also in the ocean are, of course, critical. That means in many cases, transport processes and also interfacial exchange processes are involved. From this aspect, we may also establish common scientific background, and we can also learn many things from other fields so that we can actually establish the science to realize carbon neutral energy systems. In this research division, of course, there are several technological approaches, including the alternative fuel cell device concept. We can also still have now the many good ideas which may be also realized in the future. Alternative electrolyte and electrode materials are very challenging, but could be the breakthrough for the future generation fuel cells. And for such research, of course, the fundamental understanding the processes in such electrochemical devices are very important. In this division, there are 4 principal investigators. I think it is not to mention Professor Harry Tara is the world authority in this electroceramics, and he will also chair the afternoon session. And Professor Gaukura, he is also very famous in the ceramics processing, and that is also my supervisor. Therefore, I know him, of course, more than 20 years. And Professor Nakashima, he is also very famous in the nanocarbon materials research. And in this team, we may also consider actually the fundamental aspect of the fuel cells. In addition, of course, I should also mention that Professor John Kilner is sitting there. He will give also a talk in the afternoon. He's also world authority in the solid state dynamics and especially ionic conductors. And our good friend, my good friend Ishihara, he's head of the hydrogen production area, but he will also be strongly involved in this hydrogen fuel cell research division. These 6 PI teams is not just the collection of the famous scientists. We can just actually cover the broad aspect of the fuel cells. Because fuel cell, depending on the operation temperature, we may also use the different type of materials. We should also consider the electrolyte, electrode, and we should of course consider how we can design the device, actually fuel cells. And we hope that we can also make the good discussion to establish the actual science of the fuel cells. In this division, we have the focus to 2 types of fuel cells. Of course, one is solid oxide fuel cells, because that could show the very high energy conversion efficiency. But also, the polymer electrolyte fuel cell research are very important because actually that is the type of fuel cell which may be also applied for the fuel cell vehicles. We have, of course, not enough time to discuss the detail of the research plans. We have already written in the white paper, and that will be also reviewed by the external reviewers. I just want to show one example how we actually define the research topics and what could be the output of this research. Of course, the multi-fuel capability is very important so that we can, for example, develop the fuel cell vehicles operating with hydrogen, but also which can be also operated with the other type of fuels, for example, containing hydrogen, but also other hydrocarbons, for example. We should also ensure, of course, the long-term durability of such high-temperature energy systems. From scientific viewpoint, such research is just based on the thermochemical stability of such materials at a high temperature. And from such understanding, we can also actually consider the durability. That is actually a technological problem, but we can convert this technological problem into the scientific world so that we can solve this problem from scientific aspect. We are also working to use, and of course not only the hydrogen, but also hydrogen-containing fuels, for example, alcohol, but also biogas are of course very attractive as a fuel for such high-temperature fuel cells. We have also demonstrated already that could be also work, but there are many scientific problems behind. Recently, we are very exciting to work with the alternative electrocatalyst because many people know that we used the carbon-supported platinum as an electrocatalyst. Of course, the carbon-based such catalyst will be also used or the cathode, that means the oxidizing electrode, where the air with the high humidity will also supplied. That means we should use the carbon in the oxidizing environment, and we have platinum that is a very good catalyst for electrochemical conversion, but also good catalyst to oxidize the carbon. One solution is very simple. we just used already oxidized materials. And based on this concept, we have developed to prepare the semiconducting oxide-supported electrocatalyst, and we have shown the considerable increase in the durability of such electrocatalyst. And that is actually simulating the startup of the fuel cell vehicles in daily use. And recently, we have shown that this type of new materials developed in our laboratory has been tolerated up to the 60,000 voltage cycling. That is almost a lifetime of 20 years if we start up every day, maybe 8 times startup in every day daily use. There are also other topics. Professor Talla will also have a focus for the nanoionics effect. And we want to understand the grain boundary and interface processes. And we may also use the model electrode to understand the fundamental issue, including the atomic defect, transport property, and also electronic structure in these materials. Of course, there are many interesting materials where he has developed, including the nanocomposite materials, but very thin micro devices. And also printing method has been also developed, which could be also useful for further materials research. Professor Gaukura is also famous in the micro solid oxide fuel cell, where he can also realize the fuel cell operation below 500 degrees Celsius. And by using this technology, of course, we should also understand the surface and interfacial processes. That is a very scientific issue. But if we will solve the problem, we may also realize the portable devices using these fuel cell technologies. There are many technological issues and also technological scientific aspects involved in this project, and we hope we can work together for the scientific point view, but also technological viewpoint. And Professor Nakashima, coming from the applied chemistry department, he will also concentrate to the nanocarbon materials, and also his colleague is a specialist in the polymer-based new alternative electrolyte materials, so that we may also work together in the field of high-temperature polymer electrolyte fuel cells, but that is also a very important aspect. And for the electrolyte, we may also apply the proton conducting type, but also alkaline conducting type fuel cell could be also very interesting. We have enough infrastructure to start these activities. Now we have actually the 40 fuel cell testing unit, which can cover high temperature fuel cell research, low temperature fuel cell research, but also polymer electrolyte fuel cell research. And we have also other facilities for various fuel cell analysis. But I think I would like to mention we are very proud that we already have the good team in this fuel cell research division. And so that we can also cover various aspects, fundamental aspects in fuel cell science. And that could be, I think that is good as a startup to realize and establish the scientific basis of these electrochemical devices. And also, we would like to propose the fundamental design principles for the materials and devices in this very important application, so that we hope we can contribute to realize the carbon neutral energy society. Thank you very much for your attention.
Thank you, Professor Sasaki. In Japan, the ordinary people understand that fuel cell is a kind of battery we use at home, but fuel cell is not the battery. And for the outreach of our WPA activity, I think we need a lecture like the one given by Professor Sasaki. Or the official discussion for this keynote lecture will be given Professor Tara of MIT.
Well, thank you, Professor Sasaki, for a very nice introduction. Obviously, the field, as you mentioned, is highly interdisciplinary. We mentioned that the I²CNER program is supposed to develop the science behind the engineering. What can we do to obtain the interests of a broader range of young scientists to come into this field? Obviously, the field sounds like electrochemistry, but we need physicists, we need electrical engineers, we need chemists. What can we do to broaden that appeal?
That is a very important question, and of course, as I think the audience has realized, there are many research topics which is good for example, physicists, or for example, for quantum chemical calculation, we may also need such fundamental scientists. I think within our university, we have now actually the project where almost more than 40 researchers are involved from various interdisciplinary research divisions, so that we may have the broader group, not limited to the material sciences and electrochemistry. And then we may also consider that this type of research topics are so important and interesting, so that various type of research, the researcher from the other discipline may also join and learn, and what kind of interesting topics are existing in these energy technologies. I think, for example, the battery and fuel cell are so important, become so important in the society, and I think I have also feeling that young researchers had interest, young researchers from in the different and other divisions has a strong interest for these technologies, and this WPI gives a good opportunity for those researchers from different disciplines. Yeah, I hope it could be the question, answer to the question.
I have one further question, and that is, we've seen that in the introduction of alternative energy fields, there seems to be kind of a critical breakthrough that needs to be made for the technology to really be implemented broadly. So solar energy has been around for many years. Just now it's really beginning to penetrate into the marketplace.
Yeah.
Fuel cells, as you mentioned, is starting to show up in many various places. But what do you think will be the key challenge to really see the broader implementation? What do we need to solve about fuel cell technology?
Of course, that is also topics we cannot easily conclude to this question. But I think the fuel cell research, my personal opinion is that fuel cell research is limited to the small number of specialists. We should establish actually science, or the general science, so that many people can also learn. For example, if you see the solid-state electronics, there are also textbooks, and everybody will learn this fundamental aspect. It's based on fundamental issue like the solid-state physics, for example. I think we should also establish the science of solid-state ionics, so that many other people can also easily learn and go into our field. And that is actually one of the important topics of this WPI and the task of this WPI. This is my opinion.
Yes.
Thank you, Professor Tara, and thank you, Professor Saki, again.